All right. Hello and welcome. Just let me know how everything goes, how the sound is. We got TikTok over here, we got YouTube over here. Just a quick note if you are watching on TikTok, once I get to the third part of this, it's not going to be on TikTok. Anyways, welcome to Maddie Live. We're going to be trying a new format today. We're going to have three sections. So, first, I'm going to chat about the Fermi Paradox, and I'm going to talk about two new hypothetical solutions that yours truly came up with. And then I'm going to talk some fascinating Pluto facts. And finally, we'll get into some fun universe sandbox experiments at the end, playing around with Earth's tilt, orbit, and rotation. So, like I said, just a quick note, if you're watching on TikTok, you're not going to be able to see the screen share on that last part. So once I get to that stuff, you're going to have to come on over to the big red button. You're tuned into Maddie Adams. Let's learn together. So first, before we get into the experiments, I'm really excited to present to you two new possible solutions to the Fermi Paradox. For those of you who are unfamiliar, the Fermi Paradox basically asks, where are all the aliens at? If there are trillions of stars and an untold number of planets, why haven't we encountered other intelligent life? If there are dozens, if not hundreds, of solutions to this paradox. So I'll go over a couple of the more popular ones first, just to give you some quick understanding if you're not totally familiar, before I get into my own hypothesis here. Sorry, just going to zoom out on my script a little here. Trying to multitask and do quite a few things here. Alright. So one really popular solution to the Fermi Paradox, and one that I think about quite often, one of the more famous ones really, it's called the dark forest solution to the Fermi Paradox. And keep in mind, these are all hypothetical solutions. This is all a little science fiction-y. But this solution states that basically, perhaps the reason we don't run into aliens is because the universe is like a dark forest, full of wolves and other predators, waiting to devour a less civilized species. This proposed solution contains a hidden danger. Stop sending out radio waves and signals everywhere, right? We assume that someone friendly may find them, but we may be simply inviting our own doom, similar to how a child would put themselves in danger wandering out into a dark forest alone. Or what about the similar zoo hypothesis, which states that perhaps aliens simply watch us, the way that we watch animals at the zoo, or the way that we leave uncontacted tribes alone so that we don't influence them or give them diseases? In Star Trek, Starfleet officers weren't allowed to interfere with other civilizations. This was called the Prime Directive. So if you're familiar with Star Trek, you already are kind of familiar with this idea. Another possible solution. Sorry, just one second here. All right, sorry about that. So, another possible solution to the Fermi paradox, and actually my favorite, and what I believe to be the most likely, is called temporal spatial isolation hypothesis. So I did a quick short on this one already a little while back, but basically it says that perhaps space is so vast that time and space don't allow for us to ever meet other civilizations, that it would take us extraordinary amounts of time and energy and resources to reach another alien civilization. If we were able to find them, they might be gone by then, right? So let's just do a quick example here. Let's say we find a possible civilization 5,000 light years away. And let's assume that we can actually travel at the speed of light. Two huge assumptions. If we did manage to unite the world, gather the resources, and send a ship there, we would be arriving over 5,000 years later than what we see because of how long it takes for the light to travel to us. So it's quite likely by the time that we even got to this planet, the time and distance are simply so vast that they could have already wiped themselves out. Or it's possible that the resources required to get up to the speed of light just simply don't exist in any one system without really destroying your own planet or civilization destroying itself, okay? So, on to one of my fun solutions that I came up with, and correct me if I'm wrong, but I looked around. I found some similar solutions to the Fermi hypothesis, but as far as I know, I came up with this one. So, like I said, just fun science fiction stuff. So, All right, so this one's called the cosmic isolation hypothesis. Basically, what if aliens did get smart enough to build starships, but then they got distracted by their own virtual playgrounds? You know, think about Ready Player One, but universal. They invent hyper realistic VR, they plug themselves in, and they never look back. No more rockets, no more colony ships, just entire civilizations choosing to live in the digital world over the messy real world. You know, you guys are hanging out here with me right now, aren't you? So, again, I call this the cosmic isolation hypothesis. Aliens are out there. They're just all online with no interest in really going anywhere else. So, my second solution to this hypothesis, I kind of came up with watching football, and I did kind of a smart aleck short about it. But um, we tend to assume that intelligence goes up in a straight line in a linear fashion. Like a football player, we just assume keeps improving forever, right? And you can use any sport or any competitive thing, even chess in this example, right? But you know, if you've ever played Madden or something, right? If you do a franchise, it's really easy. If you get a young team, young players, they're all going to develop, they're all going to be great, right? But in real life, that doesn't really happen. People get injured, they have problems in their personal lives, and people don't reach their full potential all the time. Players plateau, they regress, they burn out. Maybe civilizations do too. Maybe we hit a peak, smart enough to invent AIs, automation, endless entertainment, and suddenly all of that brilliance just makes them lazy. Curiosity fades out, progress stalls, and instead of shooting for the stars, they settle into cosmic boredom. I call it the peak intelligence theory, or more bluntly, do smart aliens get bored like us? Okay, cool. Just want to make sure my sound's good. All right, so maybe the answer to the Fermi paradox is that nobody's out there. That they are out there, but they've either gone digital or they've gone stagnant, right? So either way, the universe could be full of aliens. They're just ignoring us. So I love contemplating about this stuff. It's just really interesting. And let me know. We can do some more Fermi Paradox stuff in the future. I would really highly suggest that you check out John Michael Gaudier. He does YouTube videos. He's a science fiction author, and he's the one who really got me into researching the Fermi hypothesis or the Fermi Paradox in the first place. He has like over 200 videos on it. They're like 10 minutes long. So I would really highly recommend him. So next up, I'm going to click my little background here to the next page. No, not that one. All right, now we're going to do Pluto because I've been spending a lot of time thinking about Pluto and why it's not a planet and stuff like that. So I just thought it would be something that would be interesting to share with you guys. So let's go over 10 really fun facts about the most famous dwarf planet. And like I said, as a bonus, we'll discuss why it's not a planet anymore and if it should be. So number one, Pluto was once the infamous Planet X. Pluto was discovered in 1930 by Clyde Tombaugh at the Lowell Observatory in Arizona, and it wasn't a coincidence. Scientists had been long hunting for another planet and to explain the oddities in Uranus and Neptune's orbit. Just as we're still searching for a new Planet X or Planet 9 today, a planet that lies out even further than Neptune or Pluto, scientists in the early 1900s were doing the same. In fact, the idea of a Planet X has always been a moving target. I did another video on what X and dark mean, so make sure to check that out. But I don't have it linked there yet, but when I make this into a shorter video, I will. But basically, they're just placeholders for things that we think should exist. This is dark and X, right? But we still haven't been able to find them. So that's dark energy, Planet X, right? All of these things, it's like the math and our theories say that they should exist, but we haven't been able to find them, right? So that's all dark and X really mean when you break it down to its most simple terms. So astronomers are still searching for another object further out than Pluto, and based on the tug and the wobble of the sun, we think something else is still out there, substantial-ish. So number two, Pluto's name. The name Pluto in 1930 was suggested by Venetia Burney, an 11-year-old schoolgirl in Oxford, England. So an 11-year-old girl thought that the Roman god of the underworld was a fitting name for this planet. Kind of dark for an 11-year-old, if you ask me. But her grandfather passed the name along to an astronomy professor at Oxford, and the rest of it was history. Disney must have thought the name sounded catchy because later on in the same year, 1930, Disney's Pluto the cartoon dog first appeared. You know, what a year for an 11-year-old, seriously. Number three, Pluto's size. Pluto is actually really tiny. Now, this isn't the reason it's not a planet anymore, but it's only about two-thirds the diameter of our moon, which is still large enough to make it the largest known dwarf planet. But to put that in perspective, it's only about half the width of the US. Like I said, not the reason it was reclassified, though. Number four, Charon. Pluto has five moons, but its largest moon, Charon, it's about half the diameter of Pluto. This makes it the largest moon relative to its host in the solar system, and some scientists even refer to it as a binary or a double dwarf system because the mass is about 12% of Pluto's. So it's enough for it to tug on Pluto, and the barycenter, the area that they both orbit, is actually outside of Pluto. So they're both orbiting an invisible area, the barycenter, in between the two of them, closer to Pluto, though, making them a truly unique couple. And of course, that segues us into number five quite well because you all know that Pluto is a romantic planet. It has a giant heart glacier. So besides its romantic entanglement with its partner, as I said, it has a huge glacier the shape of a heart. It's made of two different parts. The left lobe is the Sputnik Planitia. This is a vast, young, active nitrogen glacier. And the right side is mostly water ice, coated with methane frost. So, while it looks romantic, Pluto has a literal heart of ice, just like your ex. Pluto, Charon system's other moons. So the Pluto-Charon binary pair have four other moons: Nix, Hydra, Kerberos, and Styx. And if you work in IT, I'm sure you will know Kerberos. They're all smaller, with the largest of the four, Hydra, only being about 65 kilometers across. Unlike our moon, which is tidally locked and has a generally predictable orbit, these four moons have erratic orbits and rotational periods. And more research still needs to be done, but it's likely due to the moons orbiting in a binary pair instead of a single object, the three-body problem. So it's believed that these moons may be the remnants of the initial Pluto-Charon collision, which brought them into binary orbit together. Number seven, icy mountains. So we've talked on this channel about the massive mountains and canyons of Mars, but Pluto is crazy rugged, and its icy mountains rise 10 to 13,000 feet high, 3 to 4 kilometers. So while they're not quite as tall as the Tharsis megavolcanoes on Mars, they're actually much steeper and more jagged. Mars's shield volcanoes, like Olympic Mons, are built from layer after layer of lava flow building up, but Pluto's mountains look more like the Alps or the Rockies than volcanic domes. They're sharp, jagged, steep. They're not as tall, but I think they're more impressive, and especially given the size in comparison to the planet of Pluto itself, which is so much smaller than Mars. Number eight, possible cryovolcanoes. New Horizons spotted features like the Wright Mons and Picard Mons, which look a lot like giant shield volcanoes. It's hypothesized that instead of lava, they may have erupted slurries of water, ammonia, or methane. And if it's true, then this means that Pluto could still have some internal heat and maybe even a subsurface ocean, interestingly enough. Number nine, Pluto has weather and probably a blue sky. Its thin atmosphere of nitrogen, methane, and carbon monoxide snows down onto the surface. Frozen ices at the Sputnik Planitia and sublimate into gas and sunlight, and then they refreeze elsewhere, driving a bizarre but definitely active weather cycle. Number 10, we've only been to Pluto once. That's why you always see kind of that same image of Pluto with the heart on it. In 2015, NASA's New Horizons spacecraft flew by Pluto. That single flyby gave us everything that we know about Pluto's geography, moons, and atmosphere. So before 2015, Pluto was just a blurry smudge. New Horizons revealed a surprisingly complex and beautiful world, but there's still so much more to learn. All right, so that concludes Pluto. And by the way, the reason Pluto isn't classified as a planet anymore is because it can't clear its orbital path of all the debris. It's in an asteroid belt. So I think essentially the idea behind that is that it's not large and dominant enough, even within its own orbit, to have coalesced all those asteroids into one large piece, right? So there are three criterion for something to be a planet. That is the third criterion, and it doesn't match that. The other two criterion are that it has to have enough gravity to form it generally into like a ball and a somewhat circular shape. So there you go. That's why Pluto isn't a planet anymore, but let me know what you guys think about it. I know with my shorts and stuff, guys, I get a little snarky and, I make jokes and stuff. And, really that's just to draw people into the more nuanced stuff like this. If you enjoy longer discussions like this, you probably don't need the shorts as much. So if you ever watch one of my shorts and you find it like just a little goofy or something, that's why, just trying to draw people in there. All right. So if you're watching on TikTok, that kind of concludes the portion you're going to be able to watch. So I'm going to end it now because, like I said, for this next portion, I'm going to be sharing my screen on the big red button over here with Universe Sandbox. So I'm not going to keep the TikTok going. So I'll turn off the live here. Thanks to everyone on TikTok for tuning in. How can I just freaking end this? Power. All right. Now we are just back to YouTube, people. So let's get into some fun simulation kind of stuff here. I'm just gonna switch up my stream. Please stand by. And there we go. Here's our Universe Sandbox. So, somebody asked me the other day, hey, in Universe Sandbox, can you change the obliquity and the tilt and the orbit? And the answer is yes. So, that's what I was going to do today. Now, realistically, in real life, even just the tilt and the axial precession and wobble of the Earth make huge, massive influences on our weather. And this is referred to as the Milankovitch cycles. I talk about this more in depth in my deep dive on climate that I did. It's just like a quick little 10-minute climate video because Rogan and Bernie were talking about some climate stuff, and I just thought that I had to address it, even though I don't really do that stuff, climate stuff on this channel for the most part. But here we go. So, this is our good old Earth here. I always, like I said, I like to get a little baseline just so we can remember where everything is at, right? So, get out my handy dandy notebook here. So the distance is always going to remain similar to 1, but remember in some parts of orbit we come closer, in some parts we come further. Alright, so the speed is 30.2 kilometers per second. Obliquity 23.4. Argument of obliquity 168 degrees. Yaw 323. Rotational period, obviously about a day, but it's 0.997. Okay, that should be good enough. So, let's start, I guess, by... because we've already tidally locked Earth recently when we did our episode about the red dwarfs. So let's speed it on up, I think. That could be kind of fun. Let's speed up this rotation here. Motion, rotational period. So, times 2. If I want to go faster, we actually would want it to be a half a day, I would think, right? Do, do, do. 0.5 days. Try this. Does this slow it down or speed it up? Yeah. Okay. So now we have a faster orbit. So we're going orbiting twice as fast as we are. So the first thing I'm wondering, is that going to do anything to our moon? Is it going to slingshot the moon out? What's it going to do to our seasons? You know what? Let's go absolutely crazy here. Let's do 0.1 days. So we're actually going to speed it up by like 10. So now we have a super fast spinning Earth. You think that's going to displace some of our water? It looks like it is already. Yeah, I think so. All right. Alright, I'm going to speed this up a little bit, let it rock, and we're going to see what happens to our Earth. And then after that, we'll mess with the obliquity a little bit. Just get a little bit crazy. Oh, wow. What happened to Africa here? Okay. We've got some big changes going on already. Let's turn on our lights. Whoop. So we'll turn on the lights. Nelly Furtado. Oh, wow. Is all the water just sucking down to the southern hemisphere? Whoa. What's going on here? Like, what is actually happening? You know, of all the things in the world, I didn't think that just spinning it really fast would make more changes than I've pretty much ever seen. Yeah, I think spinning it so fast, we just caused tidal waves to just wash over Africa. It's like this entire... Oh, we just have one massive current at the equator that is just unstoppable, even by continents. So all of the top of South America, Mexico have been wiped out here. Absolutely. Wow. Africa's toast. Usually Africa does okay in my simulations, but hey, not today. Not today, sir. Wow. Alright, I'll let it rock a little bit more and see what happens. Crazy. Crazy. Wow. Yeah, so on this Earth, you don't want to live anywhere near the equator, basically. It's pretty crazy. Just giving it a little bit more time here. I wonder how fast we have to spin it to make it start just kind of shred itself apart. Because like I said, right now we're going fast enough that we have just a tidal force going across the equator, just completely wrecking everything. So let's make it 0.05. So now we're going to be rotating 20 times faster. Oh, look at this. What's going on here? Immediately had some changes, had the land kind of stretch. Let it go for a second and then we'll check again. Let's see if any of this other stuff here has changed. So the Earth itself has actually, it appears to have slowed down a little bit by about 1 kilometer per second. Obliquity is the same. The argument has gone up slightly from 168 to 170. And obviously the rotational period changed because I manually changed that. Wow, look what we have now. If we go like really slow here. So this is your new Earth. It kind of sucks though, because a lot of the warm areas, the tropics, it'd be interesting. You would have like instead of having a north, kind of eastern and western world, we would have a northern and southern world, I think. Because look at this. You have a inhabitable Antarctica slash like a whole bunch of mud, just all. I guess all the tidal waves and stuff just moved mud and silt and land down here. Because look how massive Antarctica is right now. If you're just joining, I increased the rotation of the Earth by 20 times right now. So we had tidal waves kind of just go through the middle here and just rip everything apart. Do I have no volume? Are you serious? If you're just joining, I increased the. My volume is fine. I'm on it on my phone. It's actually should be pretty loud. I actually turned my volume up a little bit this time, so you shouldn't have to like have your phone all the way up at max volume just to hear me. Look at that. All right. I wonder how fast we have to spin it to just for it to just start shredding itself apart. 0.05 days. How about 0.005 days? Oh. Yep, there we go. I made an explosion. Yep, I made her rotate too fast. Bye, Earth. That was pretty cool, though. Like I said, I thought of all the time I've been playing this game, I think that's the most drastic changes I've ever seen to Earth, just from speeding up the rotational period. So it does kind of worry you when we, I mean, it's not going to happen in our lifetime, but if we ever lose our moon, you know? If an alien wanted to take us out, they wouldn't even really have to bomb our planet. They could just launch projectiles into our moon to either move it into us or away from us, right? Oh, that's beautiful, though. Aww. Hope everyone's having a great night. Yeah, no, there's some parts, Danny, I just might not have been talking to. Wow. Well, yeah, the moon is just orbiting the sun now. It'll probably absorb some of this. Speed it on up a little. Speeding her on up, boss. Slung. Yeah, if you're just joining, make sure to later on go back and take a look. I did some fun. I came up with my own hypothetical solutions to the Fermi Paradox. I talked about that a little bit. Did a little bit about Pluto. And then later on, I'll cut those up into documentaries with some editing and stuff. So, yeah. So now our moon is getting enveloped by all of this. I don't think the moon's big enough to really, like, look, it's not even really absorbing that much. Inconsequential. Wow, that was cool though. Alright, I'm gonna go back. All planets, all moons. That was fun. I'm gonna do that. I don't want to tear it all the way apart. So here we go. Let's go to motion again. So at 0.05, we had massive tidal waves kind of knocking everything out. That's the rotational speed, by the way. So at 0.05, it was totally messing things up, and then at 0.005, it shredded itself. So let's go to 0.02. This should be an extremely fast rotation. Oh! Okay. Wow. I'm gonna have to do that again slower. That was awesome. 0.02. All right. So what do you guys think? We haven't ran into aliens yet. And there are dozens and dozens and dozens of possibilities, but I'm curious what you think. Are they just watching us, but they don't want us to know? Okay. Super duper duper slow. Then we're gonna go motion. 0.02. I liked that. So essentially we're increasing the speed by 50. The rotational speed by 50. 50. Alright. Wow. Sweet. Yep. Just cannot be held together anymore. Gravity is too weak of a force at this much of a rotation. I did do two Earths orbiting each other. Now, one thing that would be interesting, though, is just making like a double Earth. I think I did two Earths orbiting each other the last time. It actually didn't do much. It just made the tides a little bit bigger, but like, you just had two Earths, basically. It was, now obviously the closer I put them together, now you'd start getting some more issues. Wow. I'm just enjoying looking at this right now. Yeah, so I hope you're enjoying the new format. Like I said, kind of do some... I'm trying to find a nice way that I can do simulations and some shorter documentaries and get a lot of content all out there. And so I was like, hey, I'll just do it all on the live, get a lot of stuff out there, and then I can cut it up and edit it throughout the week and get... That way you guys can get the little more important parts throughout the week, you know, if you missed it or you weren't able to attend the live, so... That's sweet. I think this is definitely going to become a short. Gravity is considered a weak force. Yeah, and you know what's interesting is gravity is one of the hardest things. Not that I even should spend that much time arguing with flat earthers, but gravity is one of the hardest things to defend against them because we haven't actually really been able to, like, we know gravity exists. You know, we can see apples fall. We can see moons going around planets. Like, we see, you know, the sun being tugged by planets. We see Jupiter tugging on the sun. We know that it exists, but we have not been able to actually, like, find it, right? Only if gas giants orbiting in our normal paths. Yeah, like if the gas giants were all way closer in and no rocky planets. 1 second. Replace. All right. So yeah, we could do that actually. So let's see, should I get rid of the gas giants that already exist? How about this? Let's do like, we'll do the old switcheroo. So I'll replace the gas giants with the rocky planets, and then I'll replace the rocky planets with the gas giants. Let's see, there should actually just be a little replace button here. Let's see. Well, there's the actions tab. Hold on 1 second. I'm just looking through some universe sandbox stuff here. Switching any planet with another planet instantly. I really thought that there was a button to replace an object. Some of the forums are saying there's not. Let's see here. Really? There's not a way to do it? Let me see here. The Actions tab. I don't even have an Actions tab. I don't know. Well, that sucks. I'm going to try to do this right. I know I'm live, but the last time someone asked me to do this, it seems like there might not be the option. Let me see here real quick. ChatGPT for the win, I guess, because these forums are not being super helpful right now. Universe sandbox. Info panel, scroll down. Let's see, do you guys see a replace button anywhere? Fly to, land, add moons, add rings, tidally lock, explode. Auto orbit, we can slow it down, speed it up, edit surface, inspect, settle liquid. But no, just replace. Ah, there it is. Yes, yes, yes. Okay. Sweet. All right. Sorry about that. All right. So let's replace Jupiter with Earth. All right. So Jupiter's Earth now. Let's go to Saturn. We will make Saturn Venus. We'll make Uranus, Mars. I know I'm kind of doing them out of order, but replace. Yay, we learned something new today. We can actually replace objects. Mars, and then we will make Neptune into... Dude, this is going to go totally wild the second I press play, by the way. We'll replace Neptune with... Well, Mercury's the only one I didn't do yet, right? Yep. Mercury. Alright, so now the gas giants are all the rocky planets. And then we just have to do the opposite in here. So I'm gonna guess everything's gonna get sucked in, but I'm not totally sure. So we will make Mars Jupiter. We will make Earth Saturn. We'll make Venus into Uranus. Crap, what did I just do? Gosh darn it. Alright. I'll be quick this time. Alright, pause. Slow. And we'll do them all in order now. There we go. Additional actions. Why do they hide that there? That's such an odd place. You'd think replacing would be pretty popular. Okay. The gas giants will get sucked in, but I feel like... Yeah. I don't know. I think the rocky planets and all their moons are going to get sucked in, but let's see. Alright. So we'll do them in order now. So Neptune is Mars. Uranus is going to be Earth. So Earth's going to be really cold. Saturn is going to be Venus. Jupiter is going to be Uranus. Crap. Sorry, I said like a total brain fart there. Mars, Earth, Venus. Oh yeah, Jupiter's going to be Mercury. Doop. Pum. And Mars. Mars, you are going to be... Let's see if we're going to do it all in order. Mars will be Neptune. Earth will be Uranus. Nice. Venus will be Saturn. And Mercury will be Jupiter. Now, I didn't change the moons, so I think we're going to have some issues with moons too. Like, Mercury ain't holding all these moons. Venus ain't holding all these moons. Alright. I said Mars is now our furthest out planet. But let's see. Oh, what's going on here already? Something's happening here already. Did Uranus just take our moon, probably? Yeah. Uranus took our moon. Alright. I figured that would happen. You would have to assume the same thing's going to happen to Mars's moons. Oh yeah. There goes all of... I'm kind of surprised to see that a lot of them are still shooting out. So this is similar to what happens... I guess actually, yeah, because this is similar to what happens if you were to just delete Jupiter. Which I guess makes sense. And you have to wonder if Mercury's going to keep some of the moons, maybe the closer ones, right? Like the Galilean moons or something. If you're just joining us, we replaced all the gas and ice giants with the rocky planets and all the rocky planets with the gas and ice giants. So Jupiter, Neptune, Saturn, Uranus are all on the inside. And Mercury and Venus are really struggling to hold on to all these moons right now. Hi, Mom. Nice. Oh boy, we're gonna have some collisions. I wonder what Earth looks like right now. Our frozen, icy, cold Earth. As cold as your ex's heart. Sorry, I need to get better jokes. Work on it. Dark out here too. Look, this is the light side. It's just like even Siberians would be struggling, you know. Still lights on. I don't know why. Let's see our like probability for life is. Yeah, what's our average temperature now? We are cold. And we're not holding on to all of these moons. Everything on the inside looks fine, like I said, until it's be interesting because all these gas giants I think are going to dominate. They're going to take most of these moons. We'll see. Let's speed it up and kind of see what happens here. just destroyed it. You know, if we are living in a simulation, what if there's just some dude sitting there and that's our universe? And right now he's just leaving our solar system alone, but he's just out there just flinging moons and stuff at other solar systems, having a good time. I'm surprised we're not getting more of them flinging into the middle here. Let's see. Oh, there we go. I was just going pretty slow. There's Io. I think Io might leave us for good. Io said, I'm out of here, man. I don't like this solar system anymore. Said, I'm out of here, man. Doesn't even look like our solar system anymore. Like, not even close. The inner part is, you know. Yeah, I don't know. He must be pretty good at this game, right? But what do you guys think? Do we live in a simulation? You know, so I talked about something interesting the other day, and I hope not to offend you if you're either religious or not religious, but when I first heard about the simulation theory, and then they come up with this term, the simulator, I was like, doesn't that really just sound like you're replacing creationism and but you're just calling the creator the simulator? I don't know. It honestly it doesn't even sound like that novel or new to me. But anyways, wait, Earth is gone. Where'd it go? We have to find it. We're still in orbit. We're just a dark, cold ice ball now, though. We're basically gonna turn into like Europa, you know, subsurface ocean probably. You know, we still have a lot of core heat, so there's still gonna be bacterial life and things like that going on, right? So I wonder if we're actually holding on to any of these moons or not. I think we're gonna hold on to some of the moons. Oh man. I swear I don't stop having fun with this game. Ooh, Titan might just kind of become its own planet. It's just gonna orbit how it wants. Oh man, actually it looks like it's gonna get slingshotted in. It's got a bunch of madness going on. But yeah, Earth, uh, we probably got like some people holding out over here, trying to live on the water still. It's water world. Nah, they're all gone. Wow, just an ice ball. Oh, that's the Andes Mountains. You still make some of it out. Wow. Chaos. There's Hyperion, the space potato. It kind of looks like a giant old potato, which I'm kind of fond of as a kind of Irish person. Yeah, some of these are like look, Ganymede now is in an elongated elliptical orbit. So moons are turning into planets, planets are turning into still planets. So much for, you know, ever being able to fly out and escape, huh? Now, actually, so what's very interesting is there's so much distance in between stuff. So, actually, even with things all close together like this, your collision odds are lower than you would think. Oh, Titan. We got a close approach here. Chasing Neptune. Oh, man. Crazy. Where is Mercury? Mercury. Imagine yourself in a Mercury. Not a sponsor. Oh, yeah. It's too bad there's no like water or anything on Mercury. It might actually be in a. Nah, it's a little too far out still, I think. Because, yeah, this is where Earth was. Now, I wonder. Alright, so this is going to be fun. I just thought of this. Since Neptune is where Earth is, what if we just, like, strip off all of this gas, you know? What do we have most of? Lots of silicate, hey? Lots and lots of water. Holy crikey. Let's do like 10% of that. We'll do a lot less ammonia, a lot less methane, a lot less helium, a lot less hydrogen. Still need less. Less. Maybe we can turn it into Earth. So we have an iron core here, right? Too much silicate still. Water. Still reduce that more. Where's our rocky core here? He said to himself. So let's try to remove. Negative. How can that be negative? Oh, there we go. Okay, so we can actually go in and look at the gas. So let's just reduce. Okay, no water gas. Oh, there we go. Lots of silicate. What else we got? Why am I still not seeing any sort of a core here? Water, no gas. Ammonia, no gas. Methane, no gas. Helium. Oh, too much helium. 0. And too much liquid helium. Oh, what the? Whatever. 0. I don't want any helium anymore. I don't know. Uranus doesn't want to become Earth, I guess. But you would think that theoretically, the gas giants have to have some sort of a molten iron core, and that if somehow enough of that gas got stripped away, you would theoretically have, like, a rocky planet trapped under there somewhere, right? Maybe. But it would take a lot to strip all that gas away. Wow. And of course, we will end today with some just smashing of stuff. But yeah, look at this. We have some of these funky orbits going on. I have a curious question for you guys. Why do you think it is? I know the answer, but why do you think it is that most things orbit in a flat disk? Why do you think we don't have more y-axis, more like vertical orbits going on? Where is Earth? That's a fair point. There it is. Still orbiting. Right there. Yeah, totally wild. I said, I think Titan, I officially dub you a planet now, because it's orbiting all on its own. It's bigger than Mercury. I say Titan is a planet now. What do you say? Alright. This is awesome. I'm gonna save this. This is like the craziest asteroid belt I think I've seen here, though. Look at that. A bunch of stuff ejected, but we are going to be left with a nice little solar system. But nothing's going to be habitable in the inverse solar system unless we make the sun bigger. Okay. Since Earth is so far out, let's just make the sun bigger. Maybe that will help us. Or maybe it will cause extreme doom. Alright, so the sun is now 50% more massive. What's that going to do for us? Can we make Earth habitable way out in the extreme icy cold depths where Jupiter lies? Here's Earth. Are we thawing out at all? Maybe a little. Let's see. 2 masses of Earth. Like I said, you notice as stars get much more massive, the radius, so even though it's 2 times the mass of the sun, it's only 1.26 the radius of the sun because it all keeps getting compressed. Alright, is Earth habitable yet? Or are we thawing back out? Let's see. Got a nice, balmy negative 293. Man, we're gonna have to make the sun pretty big, I guess. 4 masses of the sun. Oh, it's pulling everything in closer now. Oh no! Oh no! But maybe Earth will be habitable again. You said Jupiter just went bye-bye? Jupiter, where are you? No, we're still in there. Still hanging out. They're just all so close. You don't realize how much farther out the gas giants are than the rocky planets. They're very far out. Come on, let's get more habitable Earth. Yeah, we're so far out there. Even though we're on this new orbit that's kind of taking us closer. And even though we have this new massive... oh, wait. Something just crashed into the sun. Did Jupiter just go through the sun? Oh, no. Oh. Yeah, it's getting, when it gets super close to the sun here, it's getting heated up. It's gonna probably eventually collide. Man, what happened there? I missed that. I swear, you can do the same thing over and over in this game, you're always gonna miss something. That's why it kinda like never gets boring. Earth, where are you? I'm starting to see a little bit of thawing. I don't want to make the sun too much bigger. Screw it. Let's do it. 600? No. 6 masses of the sun. Sorry, Jupiter. Jupiter might be gone now. You know what? Yeah, that makes sense. Jupiter is the closest planet, and I keep making the sun bigger, so... What is a Jupiter to do? It doesn't have any more space. What is a Jupiter to do? Just keep getting lit up, I guess. So this is our new inner solar system. Chaotic. Do you think life could ever exist in a chaotic solar system? Like if most of the solar system's just chaotic and crazy like this, but maybe you do have one planet that somehow manages to maintain life? Wow. Crazy. So if you're just joining us, we replaced all the rocky planets with the gas and ice giants, and we replaced all the gas and ice giants with the rocky planets, and then now the sun is also 6 times more massive. Because I'm trying to, even though Earth is orbiting out at where Jupiter normally is, I'm trying to get it habitable, but it's just a giant ice ball now. Alright, 10 masses of the sun. Bye, Jupiter. Figured that would happen. Should be outputting a lot more energy now. I mean, look, it's white now. I heard some kind of sad news today that, you know, G-type yellow stars like our sun, we think only make up maybe about like 2% of the stars out there. And so that could also be a challenge to finding life. Maybe red dwarfs just aren't suitable for life, which, you know, that would actually really help. That would make more sense, right? Because you'd be like, okay, why are there so many stars but we don't see aliens? Well, most of those stars just shoot off tons of solar flares, and the only planets close enough to them to, you know, be warm enough would be tidally locked, and, you know, all of those complications. All right. Come on, Earth. Oh, man. Whew. Look at all these little moons getting rescattered now. They're all getting sucked in and slingshotted back out. It just made everything way more dangerous. I wonder how much of the sunlight would be getting blocked, you know? Like just from... Oops, sorry. You know, all of these objects constantly in the way. Just be getting like eclipsed. Hey, look, there's Africa. Oh! Something's living right there. Wow. Crazy. That is wild. I kind of like the flower pattern that we have going on here. All right, I know how to go out with a bang, guys. So we're gonna do it. I'm gonna save it right here though, because I do kind of want to try to make Earth habitable here. Save. I'm just gonna call this Wild Wild West. When I roll into the wow, wow. Alright, let's see. Gas and ice planets replaced with rocky planets and vice versa. And the sun is 10x more massive, and everything is wild. Alright. Okay. Slow things down. Where's the sun? Jeez, how is it hard to find the sun? Did I delete the sun? Oh no. Yeah, I deleted the sun. Why did I do that? No. That's okay. I'll just put a giant sun right back here. So all I was going to do was make it really, really giant anyways. So let's find Stevenson 218, 40 masses of the sun. Jeez. So how come this is 40 masses of the sun, but it's so much bigger? It's probably expanding. Let's see. You know what? I'll just do like sun, 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 sun. Okay. Probably gonna make a supernova. Blinky, blinky, blink, blink. Why is everything blinking so much? Whatever. 100 masses of the sun. 125. Let's make it 250 masses of the sun. And let's make the radius bigger. There we go. Now it is feeding. It's feeding. I wonder if I got everything to come back in or no. Oh yeah. Well, some of these ones that made it really far out aren't. But look, even Ray looks like it's coming back. Some of these guys are just, they're too far gone. Boom, 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 boom. I hope everyone enjoyed hanging out today. That was an awesome idea, by the way, Danny. Replacing the inner and outer planets. That was fun. And I was surprised by how much just really increasing the rotation of the Earth, totally made everything go wacky. I would say that increasing the rotation by a lot was worse than making us a moon of Jupiter. So that's pretty wild. Let's see, is Earth still around? Oh yeah. We'll watch from the perspective of Earth, our universe getting destroyed. Dun, dun. Well, the good news is we'll thaw out a little bit before we, get sucked into the sun forever. Look at that. Crazy. There's Earth. Getting closer. Oh, maybe we'll actually make a pass before we die. Oh, nope, we're gone. Bye, Earth. See if we'll have any sort of a solar system left with this massive, giant, hot sun. What's crazy is no matter what happens, things will return to some sort of stability. Now, whether that means a lot of things have to get launched out, a lot of things have to get sucked in, a lot of things have to get destroyed, we will reach some sort of stability. Now, I always wonder how much of a danger it is for life. No, I can't rewind at all. Nope, unfortunately. I kind of wish this game had like a rewind feature, but in order to do that, it would also, if you think about the video processing that would take, because it would have to be essentially screen recording everything you're doing as you're doing it. So, all right, well, I think that's it for today, guys. I had a lot of fun. If you joined late, I would really recommend to go back and check out my discussion about aliens and Pluto. I said later on in the week, I'll be cutting out some shorter videos from all of this. I hope everybody really enjoyed hanging out today. I hope you have a wonderful night. Take care. Bye.